We're going to look at a couple more equations. These are not any different from ones we've done before. Just have, it might look a little different. So let's say I have an equation like negative 8 minus y equals 22. And my job is to get the variable all by itself. So right now what's happening is a negative 8 is being added to a negative y. A minus sign can always be thought of as a negative sign that's an addition. So subtracting is really just adding the negative of a number. So to get rid of this negative 8, I need to add the negative of negative 8 to both sides. That just means I'm adding 8. All that was just a long way of justifying what it is that I'm saying, which is to get rid of the negative 8, I'm going to add 8 to both sides. So I do that. And then this minus sign stays with this y. Because remember, this is really plus a negative y. So I still have a negative y here, equals 22 plus 8, and then that's 30. And then there's two ways to think of this. You can just go the shortcut route and say, anytime I have negative y equals 30, that means y equals negative 30. Just change the signs of everything. The other way to think of it is negative y really means negative 1 times y equals 30. And then you're dividing both sides by negative 1. Y equals 30 divided by negative 1 is negative 30. The last way to think about it is I have negative y equals 30. I can say I'm going to multiply both sides by negative 1. So this is a negative, understood negative 1. Negative 1 times negative 1 is positive 1, which I can leave out. I can write 1y if I want to, or I can leave that out. 1y equals negative 30, or y equals negative 30. Any way you look at it, y equals negative 30. Okay, let's take a look at another one. Let's say I had minus b over 3 plus 50 equals 100. Well, b is being divided by 3, but I don't do that first. That's immediately what's being done to b. The next thing is adding 50, and so that's what I have to get rid of first. So I subtract 50 from both sides, and I get negative b over 3. 100 minus 50 is 50. Negative b is being divided by 3, so to get rid of that, I'm going to multiply, and I'm going to multiply both sides by negative 3. The reason I'm going to do that is the negative times a negative leaves me with a positive. So I've already gotten rid of the negative sign right here. So this negative times this negative gives me a positive, and the 3's cancel. So the 3's cancel each other and the negatives cancel each other, and I'm left with b equals negative 150. Okay, let's look at another one. Let's say that I have, and I'm just copying this from something, kind of has a weird notation, don't usually see it like this, but I'm just copying it the way it's written. It has negative 6 equals, negative 6 minus x 1/9 equals negative 18. Well, I mean, you could write it that way if you want. So this just means there's an understood multiplication. Normally we write that with the coefficient in front. So normally I'd write this as negative 6 minus 1/9 x equals negative 18. And then the first thing I want to do is to get rid of the negative 6. So like in the last one or a couple times ago, I'm going to add 6 to both sides. And then when I do that, the negative 6 plus 6 is 0. Here I'm left with negative 1/9 x equals, and negative 18 plus 6 is negative 12. Now, to get rid of the negative 1/9, I could divide both sides by negative 1/9, and that's not bad if you have a calculator. But remember that a way to get rid of a fraction is always to multiply by the reciprocal. So the reciprocal of negative 1/9 is negative 9 over 1. Well, negative 9 over 1, that's the same as just negative 9. So I'm multiplying both sides by negative 9. The 9's cancel, the negatives cancel, and I am left with 1x. I don't have to write the 1. x is negative 12 times negative 9 is 108.